Did you know you perform a life-sustaining miracle over 20,000 times a day, and you do it without even thinking about it? Well, today we're going to go on an incredible journey. We're going to follow a single one of those breaths and uncover the amazing secrets of your respiratory system.
It seems so simple, right? You just breathe in and breathe out. But in that tiny, tiny pause between the two, an absolutely vital and super complex series of events is unfolding inside your body. It's a precise, life-giving process, and today we're going to follow it from the very start to the very end.
So, why do we even need to breathe? What's the point? Well, it all boils down to this one thing: cellular respiration. Think of your body as this massive city, and every single one of your cells is a building that needs power. The food you eat, that's the fuel. But oxygen? Oxygen is the spark that ignites that fuel, releasing the energy that powers literally everything you do. Without that spark, the city just goes dark. Breathing is how we deliver that essential spark to every single building.
Okay, so our journey begins the moment air passes your lips or nose. But this isn't some simple, straight shot. The air has to navigate this winding, super specialized pathway that's designed to get it ready for its crucial mission deep, deep inside your lungs. So let's trace that path, step by step. And here is our roadmap. This shows the entire path, right from the entry point at the nasal cavity, down the windpipe or trachea, and into this incredibly intricate, branching network inside the lungs. Let's follow a single molecule of air as it makes this amazing trip.
So first up, the air gets warmed and filtered in your nasal cavity before it flows down the pharynx. Then, it slips past your larynx, that's your voice box, and into the main highway, the trachea. This highway then splits into two main branches called the bronchi, one for each lung. From there, the paths just get smaller and smaller and smaller, like a tree branching out through the bronchioles, until they finally reach their destination, millions of these tiny little air sacs called the alveoli.
You know, it's kind of wild to think about the air you're breathing right now. It's filled with dust, pollen, all sorts of tiny particles. But your body has this brilliant built-in air purification system. The passages are lined with tiny little hairs and sticky mucus that act like a high-tech filter, trapping all these intruders before they can damage the delicate tissues in your lungs. It's an incredible first line of defense.
All right, so the air has arrived at its final stop, the alveoli. This is where the real magic happens. It's the climax of our journey, a critical handoff that all takes place at a microscopic level. This crucial step is called external respiration. This is the moment of truth, where the oxygen you just breathed in leaves the outside world and officially enters your bloodstream. It's now ready to be whisked away to every single corner of your body. And this is where that exchange happens. The alveoli are surrounded by this dense web of tiny blood vessels called capillaries. The walls are so thin that oxygen can just pass right through them, moving from the lungs, where there's a lot of it, to the blood, where there's less of it. And at the exact same moment, your blood offloads its cargo of carbon dioxide, the waste product, sending it back into the lungs so you can exhale it. It's a perfect, synchronized swap. Now that the oxygen is in the blood, its journey enters a whole new phase: delivery. This is called internal respiration. It's the final handoff, this time between the blood and the individual cells that are just crying out for that oxygen so they can make energy. So just imagine the oxygen-rich blood arriving at a really hard-working muscle cell. The oxygen just hops off the red blood cell and moves right into the muscle tissue where it's needed. And in return, the cell hands over its waste, that carbon dioxide, which the blood will now chauffeur all the way back to the lungs for disposal. It's basically the ultimate delivery and pickup service. So, to put it simply, external respiration happens in your lungs. It's all about getting oxygen into the blood. Internal respiration happens all over your body, in your tissues. It's about getting oxygen out of the blood and into the cells. Two opposite flows, but one absolutely vital purpose. We've seen all the tiny, microscopic details, but what's powering this whole system? What is the physical engine that's actually moving the air in and out of our lungs? Let's zoom back out and look at the mechanics of breathing. The mechanics are just fascinating. When you inhale, your rib cage expands, and the diaphragm, that's a powerful muscle at the base of your lungs, it pulls down. This creates way more space in your chest, which lowers the pressure inside and creates a vacuum that just sucks air in. Then, when you exhale, everything just relaxes, and the natural springiness of your chest gently pushes the air right back out. So, when you breathe in, your diaphragm contracts and moves down while your ribs move out, making your chest cavity bigger. This expansion is what creates that low-pressure zone that pulls air in. Breathing out is mostly passive.
The muscles relax, the space shrinks, the pressure inside goes up, and the air is pushed out. It's just a brilliant and super efficient piece of biological engineering.
This whole intricate system works tirelessly for us, but it's also vulnerable. I mean, it's constantly exposed to the outside world, and certain things can really disrupt its delicate function. So it's pretty crucial that we understand how to protect it.
You know, the biggest threats are often things we introduce into our own lungs. Smoking is, of course, a huge one, directly attacking the lung tissue. But we also face all these invisible threats from environmental pollutants, allergens like pollen, and of course, infectious agents like bacteria and viruses that can overwhelm our defenses. And when the system gets damaged, it can lead to some really serious problems. Asthma, for instance, squeezes those airways, making that pathway for air much, much narrower. Bronchitis infects those same pathways. Emphysema physically destroys the alveoli, the very place where that great exchange happens, while pneumonia floods them with fluid, making that exchange almost impossible. Every one of these is a direct assault on the incredible journey we've just been following.
Every single one of your 20,000 breaths every day is a silent, complex, life-giving miracle. This system works tirelessly on autopilot to power your every thought, your every move. So, knowing the incredible journey that each breath takes, the question isn't just how it works, but what can we do to protect it? Thanks so much for joining me on this journey.